Good morning students, myself Vinay. In first session, we have solved some numerical on basic formula of pH. In this lecture, we are going to study about numerical based on resultant pH and buffer. These are the basic formula for pH and pOH. This is for the acidic buffer and this formula is for the basic buffer. Let's start with the question. Equal volume of 3 acid solution of pH 3, 4 and 5 are mixed in vessel. What will be the H plus ion concentration? Now, this is on the basis of the resultant. So, for pH 3, the H plus ion concentration will be 10 raised to minus 3. Same way for the pH 4, the H plus ion concentration will be 10 raised to minus 4. And for pH 5, the H plus ion concentration will be equal to 10 raised to minus 5. Now, by using the resultant, so there are total 3 solutions. So the formula will be N4 V4 equals to, that will be the resultant, N1 V1 plus N2 V2 plus N3 V3. Consider they are given the equal volume. Consider the volume as 1 for each of the solution. So N4 into, so total volume will be 3, that is volume V1 plus V2 plus V3, total 3. So N1 10 raised to minus 3 into V1 we have taken consider as a 1, V2 N2 10 raised to minus 4, V2 again consider as 1, and N3 10 raised to minus 5, V3 as a 1. So the resultant concentration for the H plus will be 1.11 into 10 raised to minus 3 divided by 3, that is 0.37 into 10 raised to minus 3. Observe, got it? This is for the resultant H plus ion concentration. First of all, we have converted the pH into the H plus ion concentration for all the 3, and then we determine the resultant concentration by keeping volume as a 1. Now, see the next question. Given pH of a solution A is 3 and it's mixed with another B having a pH 2. If both are mixed, then the resultant pH of the solution will be. This question is asked in the BHU, that is a Banaras Hindu University at 2005. Same, first of all pH 3. So for pH 3, the concentration of H plus will be 10 raised to minus 3, and for pH 2, H plus ion concentration will be 10 raised to minus 2. Now they ask for the resultant pH. First of all, we are going to solve the resultant. The formula will be N3 V3 N1 V1 plus N2 V2, N3 into V3 is nothing but V1 plus V2. So considering volume as a 1, so V3 will be 2, it is 10 raised to minus 3 into V1 as a 1, 10 raised to minus 2, and V2 as a 1. Got it? V3 is the addition of V1 and V2 which we have taken as a 1. So N3, that is a concentration, will be 11 into 10 raised to minus 3 divided by 2, that is 5.5 into 10 raised to minus 3. Now we got the concentration of the H plus ion. Now we are going to determine the pH. So pH that is a negative logarithm base to H plus ion concentration. So negative log base to 10, that is 5.5, minus log base to 10 of 10 raised to minus 3, that is minus 0.7403 plus 3, that is equals to 2.259. Hope you got it. First of all, we have determined the concentration, resultant concentration of H plus ion concentration. Then by substituting the formula of the pH, we got the pH of the resultant solution. Let's see the another question again asked in the BHU. 50 ml of water is added to 50 ml of solution of barium hydroxide of strength 0.01 molar. The pH of resulting, again resulting pH. So I'm going to use the same formula, but N2V2 equal to N1V1. Now first of all, barium hydroxide will produce 2 OH minus. Now listen, the resultant, that is N2, consider total volume will be 50 plus 50, that is 100. N1 concentration is given, that is 0.01, but produce 2 OH, so multiply by 2 into total the volume is 50. So the concentration will be 0.02 into 50 divided by 100, that is equal to 0.01, or we can write as 10 raised to minus 2. Now this is the concentration for the OH minus ion. So first of all, we are going to find the pOH. So pOH is nothing but the negative log base to 10 of the OH minus ion concentration. So negative log base to 10 of 10 raised to minus 2, that is 2. So what is the pH? pH will be 14 minus pOH. So 14 minus 2, the answer we get is 12. Hope you got for the resultant pH. Let's move on to the buffer type of numericals. See the question, a buffer solution has equal volume of 0.2 molar ammonium hydroxide and 0.02 molar ammonium chloride. The pKb value is given, that is 5, to determine the pH. It is a base, so pOH for the buffer will be pKb log base to salt upon base, concentration of base. So pKb is given, that is 5 log base to 10. Salt concentration, this is the salt concentration, that is 2 into 10 raised to minus 2, and base concentration, that is 2 into 10 raised to minus 1. So pOH will be 5 plus log base to 10 of 10 raised to minus 1, that is 5 minus 1 equals to 4. So we got pOH equals to 4. So the pH will be 14 minus pOH, that is 14 minus 4, that is equals to 10. Call the numerical for the buffer. This was the basic buffer and they asked for the pH. So by using the basic buffer formula, we have determined the pOH, and by substituting the value we get the pH, that is equals to 10. Let's see another question asked in AIEEE. Component of a buffer solution are 0.1 molar SCN and 0.2 molar NaCN. What is the pH of the solution? Now this is the acidic buffer. So going to use the formula for the acidic buffer, that is pH equals to pKa plus log base to 10 of salt upon concentration of acid. So pKa is given, that is 9.30 log base to 10 of Salt concentration, salt is 0.2 upon acid, that is 0.1. So 9.30 plus log base to 10 of 2, that is 9.30. Log of 2 is 0.3010. So get the 9.60 as an answer. So the pH is 9.60. Let's solve another question. Okay. See the question. 0.1 mole of methylamine, that is CH3NH2. Kb value is given. See it carefully, it is not pKb, it is Kb value is given. Is mixed with 0.08 mole of HCl and diluted to 1 liter. What will be the H plus ion concentration in the solution? So there is CH3NH2 mixed with the HCl. We get a salt CH3NH3 plus and Cl minus. So initially we have taken 0.1 molar, HCl we have taken 0.08, and initially it will be a 0 initial concentration. And during the reaction, course of the reaction, 0.08 mole of HCl react with the 0.08 mole of CH3NH2, so remaining will be 0.02. It is completely reacted, so 0, and we could get 0.08 concentration. Hope so you got it. Initially 0.1, 0.08, so out of 0.1, 0.08 is reacted, so we get 0.02 as a pending base, and the salt bodies will be 0.08 concentration. Now, so OH minus ion concentration will be Kb into concentration of base upon concentration of conjugate acid upon concentration of conjugate acid. So Kb is given, that is 5 into 10 raised to minus 4 into base 0.02, conjugate acid 0.08. So by solving we get 1.25 into 10 raised to minus 4. This is the concentration for the OH minus, but we have to determine the concentration for H plus. So for the concentration of H plus, it is Kw upon concentration of OH minus. So Kw is 10 raised to minus 14. OH minus we have determined, that is 1.25 into 10 raised to minus 4. So the final answer is 8 into 10 raised to minus 11. The concentration of H plus will be, got it? Base with the acid produce the salt. So 1:1.1 and 0.08 we have mixed. So out of 0.1, 0.08 is reacted and 0.02 is remaining, that is a base, and the salt bodies will be, concentration will be 0.08. So by substituting the formula of OH minus, we got the concentration of OH minus, and then we will determine the H plus ion concentration. Okay, so the next question asked in the PMT pre-medical test in 2003, the pH of the solution of 10 ml 1 normal sodium acetate and 50 ml 2 normal acetic acid, pK is given. Acid means pH, it is an acidic buffer, so pH will be equal to pKa plus log base to 10 of salt concentration upon acid concentration. So pK is always given 4.74 plus log base to 10 of salt concentration. Salt concentration will be, concentration of the salt will be 10 into 1 normal, that is nothing but 10. So salt 10 For the acid, multiply these two value, we get the concentration, that is 100. So 100, so 4.74 into plus log base to 10 of 10 raised to minus 1, that is 4.74 minus 1, that is 3.74. This is the final answer. Got it? So first we calculated the concentration for the salt, that is we multiplied the 10 with the normality of that, and for acid we will multiply the volume with the normality given. So we have put the value of the concentration and we got the pH 3.74. Hope so guys got it. You have solved the two types of numerical, first on the basis of the resultant and second on the basis of a buffer formula. Thanks for watching the video. In next video part 3, that is the session 3, we are going to solve the pH for the titration type of numericals.